normal distribution, right? This normal distribution curve, it's a curve. When I say normal, it's normal, meaning it's symmetrical. Look at any of these curves, either this dark green or the orange one or the blue one or the light green one or the brown one, right? Everything is symmetrical across your mean. Why? Because it is normal distribution. And any normal distribution can be represented using mean mu and standard deviation sigma. Look at this blue curve. It has mean 0 and standard deviation 1. And here is a curve. Here is a blue curve, right? If I maintain the mu at the same place, and if I reduce the standard deviation to 0.5, what is happening? The width of this blue curve got reduced. The variation got reduced. Hence, the curve is a lot steeper and, it's closer to the mean. If I maintain the mu as is and if I increase the standard deviation from 1 to 2, what would happen? Look at the difference. From this blue curve, when you have increased the standard deviation to, it has taken the form of a green curve. That is a lot more wider. Right? It's a lot more wider. However, if I maintain the standard deviation as is, and if I say mean is equal to negative, then this blue curve shifts to your orange curve here towards the left because it is negative. So it's moving towards the left. If I maintain the standard deviation as is and change the mean to 1, what happens? Right? The width remains the same as in the case of this blue curve. However, since the mean has moved to 1 from 0, it moves towards the right. So all these curves can be represented using two things, using my mean mu and standard deviation sigma. Using mean mu and standard deviation sigma, I can represent any normal curve, right? It takes the form of a bell-shaped curve. This is called as a bell-shaped curve, right? And it has these following properties. If your process is operating at 1 sigma level, 1 sigma, then you will say that there are 68.25% of requirements which are meeting the customer specifications. The customer wants something, right? If your process operates at plus or minus 1 sigma, only 68% of the work that you perform is going to meet the requirements. Look at this. If there are, or let me pick up another color here. Sorry. Okay, my bad. So if there is one standard deviation difference from my mean on the other side, then it's called as 1 sigma, and there would be 68.26% of the requirements of the results of the products which meet the customer requirements. If there are two standard deviations, right, from the mean, one standard deviation and two standard deviations. From the mean, there is one standard deviation and two standard deviations, right, towards the left and right. Then you call that as plus or minus 2 sigma process. If that is the case, you will see 95% of the data meeting your customer requirements. If there are 3 standard deviations, 1, 2, and 3, from this mean towards the right side, or 3 standard deviations from the mean towards the left side, then we call that as plus or minus 3 sigma, 3 standard deviations, right? Then 99.7% of the data points are going to meet your requirements. If there are 4 standard deviations, then it's plus or minus 4 sigma. these many percent of your products meet the customer requirements. If it is plus or minus 5 sigma, then there will be so many points which meet your requirements. If it is plus or minus 6 sigma, you say that my process is operating at 6 sigma. That is also concept of 6 sigma, right? 6 sigma has 3.4 defects per million opportunities, right? If I am manufacturing a million cricket balls, there would be only 3.4 defects within that, if each cricket ball is considered as one opportunity. All right, then you have 99.99999 so much percentage of your products meeting your customer requirements, right? So that is how you infer a normal distribution and things like that. Is this clear, friends, or do you have any doubts? Is this clear, or do you have any doubts? Please confirm so that I realize that you guys are still awake. Mandar, Monica, Rohit. Rohit is not clear. Okay, which concept are you not clear? Or Mandar, you can see which concept you're not clear. Rohit, which part are you not clear, Rohit? No, can you be a little more specific? Last part meaning? All right, all right. So let us take this example. Do you all guys play cricket? Or at least watch cricket? What is the circumference of ICC cricket ball? International Cricket Council says that the upper specification, wow, Monica knows that, 229 mm, and the lower specification limit is 224 mm. This is the average. This is the average line, mean. What do you mean by standard deviation? How far away are my data points from the mean? So if I manufacture the first cricket ball, it will have some circumference, say 228 mm. Another cricket ball you manufacture, it will have another circumference 224 mm and things like that, right? Say you have manufactured 1,000 or 100 cricket balls. Say you have manufactured 100 cricket balls. All 100 cricket balls will have different circumference. Say you have measured the circumference of all the 100 cricket balls that you have manufactured. Everything will have a different circumference. Now, if I say that my process is operating at one standard deviation, that means from this mean, I'm just operating till here. One standard deviation on either side. So I cannot be exactly on the mean. Say the average of all the cricket balls is say 227 mm. If the average is 227 mm, should all my cricket balls that I'm manufacturing circumference be 227 mm? Is that possible? Is that possible? No. Right? So we agree that there will be some variance in the process. There will be some variance in the process. Right? And if the variance is in the process or the standard deviation is plus or minus 1 standard deviation, that means your process is operating at 1 sigma level. If your process is operating at 1 sigma level, that means there would be only 68.26% of cricket balls which will meet your specification limits. That means out of 100 cricket balls, only 68 cricket balls circumference would be between 229 and 224 mm. Circumference of all other cricket balls will be outside your 224 mm and greater than your 229 mm. That is what you mean by operating at one standard deviation. Just try to sink in this concept. I'll give you 1 minute. All right. So that is the logic of your process operating at one standard deviation. If your process is operating at two standard deviation, that means here you have another standard deviation, here you have another standard deviation, right? From mean, you are two standard deviations away. From mean, you have two standard deviations away. If that is the case, if you're two standard deviations away from the mean, 1, 2, 1, 2 on either side, then your process is said to be operating at 2 sigma level. If your process operates at 2 sigma level, right, out of 100 cricket balls, 95.44 or 95 cricket balls will fall within these specification limits or customer requirements of 229 mm and 224 mm. What about the rest 5% of the cricket balls? They would fall outside your specification limits, either below 224 or above 229, and customer will not accept those. Customer will say, hey, I've given you these requirements and you have exceeded those requirements. No, you are not within my requirements. I do not accept that. And then you have this 3 sigma, 4 sigma and all that. The higher you move up to the sigma, right, more standard deviations you're fitting into your specification limits. Right? For a 1 sigma process, do you know what? Your specification would be here. 224 mm would be here. 229 mm would be here. How far away is your data points from your mean to either side of the specification? 68%. That means out of 100, 68 cricket balls are falling within these specification limits. Rest of the things are falling outside. If I say we are operating at 2 sigma level, right, your specification limits would be this. Here you'll have upper specification limit and here you'll have lower specification limit. From the mean to one side of your specification limit, you are fitting in two standard deviations. That means 95% of the cricket balls out of 195 cricket balls will meet these specification limits. Rest of the things will be outliers. That means you're not meeting the customer requirements. Is that clear? If you say 3 sigma, your specification limits would be here. And 99.73% of the cricket balls that you manufacture will fall within the customer requirements. What are the customer requirements? Any cricket ball that you're manufacturing should fall within 229 mm to 224 mm circumference of that. Clear? So the more standard deviations you can fit into your specification limits, right, the more robust your process becomes. The more data points would meet your requirements. Clear? Or do you want me to explain again? I'm willing to spend additional 5-10 minutes also. So Mandar says if we move from 1 to 6, the closer we are to the standard or the specification limits, right? Yeah. No, rather than making such a statement, we would say that if we move towards Six Sigma process, there will be very, very minimal defects. 99.999% of your cricket balls will meet your requirements. I would not say standard because standard deviation and that, right? I don't want to confuse in that way. Rohit, are you clear now? All right. Monica, hope you are also clear. You can ask me if you have any doubts. All right. So that is what we have been discussing. Post this topic, we will close for today because it'll be overkill for you all otherwise. Graph of the probability density function is a bell-shaped curve. Yes, you see here that it is in the shape of a bell, temple bell and things like that, Christmas bell. The normal random variable takes value from minus infinity to plus infinity. So on this side, it's not going to touch the line, right? If you see this, you might feel that this is touching the line, but it's not touching. It goes till infinity. It's not touching. For example, your sky also, right? If you look from a far off distance, sky, you feel that the sky is touching somewhere the ground, but it never touches. Here also it is the same. This graph is never going to touch this line. Hence, it is going to range from minus infinity to plus infinity. It is symmetrical and centered around the mean. Yes, if I draw this line, it will be exactly in the center. Same number of data points would be this side on this side. It will be symmetrical. And also your mean would be equal to your median, would be equal to your mode. Mean equal to median equal to mode for a normal distribution. And any normal distribution curve can be specified using two parameters, mean and standard deviation. So you can write that my random variable x is approximately normal with mean mu and variance sigma square. That is what we have done here, right? If mean is equal to 0 and sigma is equal to 1, you represent a graph. If mean is equal to 0 and sigma is equal to 0.5, you represent another graph. So all these normal distribution probability density functions, that is what you call, right? Why do I call it as probability density function? Because instead of the raw count right here, instead of the raw frequency, you can also represent in the density terms. How dense is a population, things like that. And you know, the probability associated with any single value of a random variable is always 0. Remember that. So if I ask you, what is the probability that your sales is going to be exactly 2 lakh per month? What is the probability that your sales is going to be exactly 2 lakhs per month? It will be 0. How can you be certain about one single number? Are you a god? Are you superhuman? No, right? So it will be 0 always. How much time is this session going to take? Can anyone give me a probability that it's going to take exactly 2 hours? Can you guarantee that it's going to be exactly 2 hours? Never. There will be a difference in milliseconds at least. for your probability guess. So it is never ever going to have any value. So this is called as, you know, probability associated with any single value being 0. Probability of the values being in a range. Yes, if I say that this session will take anywhere between 1 hour 45 minutes to 2 hours. If I give you a range, if I give you this range, then there is a probability associated with that. So always probabilities are associated with ranges. Single number, never. It is always 0. So probability associated with a range is the area under the probability curve. Say this session will take minus infinity to plus infinity time, for example. If I ask you what's the probability that session would take 1 hour 45 minutes to 2 hours. I'm giving a range here. I'm giving a range for y'all. This area which is in gray color, light gray color, right? That is a probability associated with this range x1, x2. Probability associated with this range is so much. And the area under this entire curve is always going to be equal to 1. All right. If you do not understand, just by heart these. Okay. So